This is Stanford Legal, where we look at the cases, questions, conflicts, and legal stories that affect us all every day. I'm Rich Ford, here with my colleague Pam Karlan, and we're back after taking some time away. So don't forget to subscribe or follow this feed on your favorite podcast app. That way, you'll have access to all of our new episodes as soon as they're available. Today, we're here with our colleague Buzz Thompson, who's an expert in, among other things, water law. And drinkable water is clearly our most precious commodity. And only about 2.5% of the Earth's water is fresh water. And Pam, you had a little poetic comment to make with respect to this question.
Yeah, it's not my own. It comes from the Samuel Taylor Coleridge poem, A Rhyme of the Ancient Mariner, which has this refrain in a couple of ways: water, water everywhere, and not a drop to drink. And as you said, that's we have water everywhere, but only 2% of it is fresh water, which is obviously what we mostly drink. So I'm really looking forward to hearing from Buzz about this and his new book, Liquid Assets.
Buzz, welcome to the show. As we mentioned, pollution, engineering, population growth, and climate change are all posing challenges to the freshwater quality and quantity in America. And the safety and amount of water available is currently in question. Particularly challenging is infrastructure, with much of it aging and starting to fail. And there are many other challenges as well. So please just tell us a bit about the landscape. It's a huge topic, of course. But what are the most important challenges we're facing with respect to water today?
Okay. I think this is probably the most important topic. I obviously have a bias because I'm a water lawyer, but as you started out by saying, water is our most precious resource, right? We can't get along without it. And we are facing a whole series of crises at this particular point in time. We actually, as you started out by pointing out, we have more than enough water on the planet, right? But like 97.5% of that is salt water, which we cannot drink without it being desalinated. And so we face multiple problems today. The first is just an uneven distribution of water. There are areas like California or South Africa or the western coast of Australia that simply do not have enough water to go around. And climate change is going to make that all the worse. It's going to heat things up, which means that we will have more water evaporate, but we will also need more water at the same time. We have, at the same time that we are facing shortages of surface water, right, surface fresh water, we are also depleting our groundwater resources around the world. There is no continent on the face of the planet except Antarctica where we are not depleting our groundwater resources. Our traditional way of solving our problems of not having enough water, for example, creating dams and storing water when it's available, or finding a place where there is water and then transporting it hundreds of miles away to where the water is needed, has created a huge environmental crisis. So there is something called the Living Planet Index that WWF publishes each year. And it shows that our migratory fish populations in the last 50 years have dropped 75%. That's more decline than any other species around. Then add on to all of this that even where we have enough water, you want to make sure that everyone has access to that water and that that water is safe. Even in the United States, we have like over 2 million people who do not have running water in their homes. Of the people who do have running water, over 10% of them are getting their water from water supplies that don't meet the standards of the Safe Drinking Water Act. And water is becoming more unaffordable for the poorest members of our population. And then, just to add on one other crisis, we have a problem with our water infrastructure. It is aging and it is beginning to fall apart.
Can you describe what a water infrastructure is? Like when you say water infrastructure, What do you mean?
Yeah, so that's an excellent question, Pam. So when I talk about water infrastructure, I'm talking about everything from the pipes that are used to transport our water to our homes, to the dams which hold the water for periods when we need it, to stormwater infrastructure, which makes sure that our cities are not flooded when we have a huge rainstorm. And the American Society of Civil Engineers rates infrastructure, all types of infrastructure. And its most recent rating on water infrastructure, it was like a C minus for drinking water infrastructure. We don't even have C minus as a grade at Stanford Law School anymore, right? So it ranges from a C minus for drinking water to D for dams and stormwater.
Well, that's an enormous challenge. How expensive would it be to update and fix our water infrastructure? Again, I know that's a big question because it has so many different components. But is government responding to the challenge?
So let me take that question in several quick parts, Rich. First of all, in terms of what it would take, 2019, last year we had good statistics on this. We spent about $48 billion, so a lot of money, right? We spent $48 billion upgrading and repairing our infrastructure. Best guess is we probably needed to spend about $129 billion, so about 3 times as much as we actually spent. And the best estimate is that by 2039, we're going to have a cumulative deficit. The total amount of money we need to spend at that point in order to bring our infrastructure back up to par, if we don't change what we're doing, about $2 trillion. Okay, so that's the first part of the question. But the second thing is that frequently when we rebuild our infrastructure, we're rebuilding it the way it was built in the 20th century. And one of the things that we need to do is take the opportunity to actually replace that 20th century infrastructure with 21st century infrastructure and technology. So we're not keeping up with the sort of backlog, the deferred maintenance, and we're not upgrading as we go along.
Can you give us an example of a 21st century technology as opposed to the 20th century technology?
Yeah, I'll be happy to do that, Pam. So take wastewater. Okay, 20th century wastewater technology took that wastewater, treated it to some degree so it wasn't quite as dangerous, and then would discharge it into the river or the
So
ocean.
that's like a sewage treatment plant? Is that kind of what you're
That wastewater,
Okay.
that's a sewage treatment plant. That's absolutely right. And if you think about it, that's really wasteful because that water could be reutilized if we simply purified it to a degree that we could reuse it. And increasingly, cities are taking their wastewater facilities and changing them into recycled water facilities. But let's go a step further because if you take that wastewater, you can turn it into water that you can use again. But in addition to that, you can also get energy out of that wastewater because there's a lot of chemicals in that wastewater that produce things like methane that you can actually burn for energy. So you could imagine taking that wastewater, turning it into fresh water, turning it into energy, also getting out things like calcium and phosphates, which are in that and are valuable chemicals. And so the 21st technology would be a resource recovery center where rather than just discharging water, you're taking that wastewater and getting all of the valuable resources out of it. And there are a few places that are doing that, but not very many. And we could be doing it even better than we're doing today.
One of the challenges, Buzz, involves the complexity of our water system, doesn't it? I mean, I teach local government law, and water is often a municipal function. Just from your discussion, we've got some communities that are using groundwater, some that are using water from springs, some that are using runoff from snowmelt. And all of these different water systems, there's also a private component, isn't there? So is one of the challenges trying to coordinate all of these different independent water systems and get them working together?
You're absolutely right, Rich. That is one of the major challenges here. And I will add one other onto what you said, which is we have a highly fragmented water system. If you look at the energy sector is relatively concentrated, right? In California, for example, You have PG&E, you have Southern California Edison, you have San Diego Gas and Electric, you have LA Department of Water and Power. There's a limited number of large energy providers. In the water field, on the other hand, we have more water systems in the United States than we have elementary schools, junior high schools, and secondary educational institutions combined. So a lot of people in the United States receive their water from these really small water suppliers.
Are you considering like individual wells in that, or it's actual like companies that are supplying water to people?
It's actually water companies supplying people with water. In the United States, you have probably about 12% of the population receive their water from wells, right? What you're thinking about, Pam. But in addition to that, if you look at where everyone else gets their water, there are a lot of people who get their water from these small little systems that maybe serve 500 people or 1,000 people. And the problem is that they frequently don't have the money to upgrade their infrastructure. And they may only have one or two people on their staffs. And those people might not have a lot of expertise. So trying to meet the Safe Drinking Water Act, that's challenging for them.
Like, where is one of those tiny places getting its water from that it's distributing?
A lot of them do receive water from wells, Pam, getting back to your particular point. But a lot of them are also extracting water from rivers or streams, or they might get their water from a larger regional water supplier. But the bottom line is that the person, the entity that's actually serving that local population is very small.
Another issue that we read a bit about in the press, and I grew up in Fresno, California, so I have some sense of the importance of water for the agricultural industry. But there are fights over water. I mean, as the number of people that need water grows and the supply is dwindling, we're beginning to have struggles over who has access to the water. Maybe you could tell us a little bit about the legal structure around who has rights to water and whether or not that structure makes sense given the contemporary challenges we face.
One of the things that I've sometimes said about water problems in the United States, but it's also true around the entire world, is that we are trying to meet a 21st century set of challenges with 20th century technology and 19th century laws. In a lot of the Western United States, we allocate water on a first come, first served basis, something called the prior appropriation system. So if you and your ancestors were the first one there, then you have the first right to the water. And that might not always be the most valuable right or the most important use of the water. So we have, I think, two challenges here. The first is that we need to make sure that the poorest members of our society actually get the water that they need to survive. California is the only state in the country that actually recognizes a human right to water, but the United Nations has recognized it. So the first thing we need to do is to meet that human right. And that means that we need to protect the rights of those poor communities against anyone else who wants to come along and use that water instead. Once we have done that, though, my view is we need to make sure that the water goes to the most valuable use, because water is, again, a scarce resource. And as it becomes scarcer, we want to make sure that if we have different agricultural crops, for example, that those crops which are most valuable are the ones that actually get the water. And for that, we need water markets. We need the ability of those individuals who need the water for their crops, may be able to pay people who have less valuable crops, or people who can conserve more of their water.
So that's kind of interesting because it's a combination of markets which involve willingness and ability to pay, and a group of people who don't have the ability to pay. And
Yeah.
so we first give it, It's just a really interesting way of thinking about a mixture of a market system and then a system that's really not a market system at all.
Yeah, no, you're absolutely right, Pam. And it's one of the things I find most interesting about water. When you go to water meetings, you frequently have people debating about whether or not water is a commodity or water is a public resource. My view is it's both. It's a public commodity. And the reason I say it's both is that there are important public interests in water resources. I just mentioned one a moment ago, which is the human right to water. We have to make sure that the poor members of our society have access, affordable access to safe drinking water. The other major public interest is the environment. We need to make sure that we leave enough water in our rivers and streams in order to protect those freshwater species that I mentioned earlier are plummeting in their populations. So, if you think about how the law should deal with that, it needs to start out by protecting the public interest because the market is not by itself going to protect that public interest. But once we have protected the public interest, then it's really, I think, a commodity like anything else. And we want to make sure that that commodity is used in its most valuable purpose.
And so we'd be thinking about private actors intervening in a market in order to determine the distribution of water. So in some sense, that would mean disrupting or overturning the existing set of entitlements, like you said, like first in time, first in right type systems, and replacing them with some kind of a competitive market in which I assume both municipal governments that are providing water to, their population and private actors like large agribusinesses would be in some sense competing in a market for water. Maybe you could tell us a little more about how the private sector is currently dealing with water and how private involvement might work to meet the challenges that we're facing in the future.
So the first thing, let me just talk about water markets for just a second. We actually do have water markets in various parts of the world. So we have water markets in the Western United States, Australia, Chile, and to some degree in about half a dozen other countries. But more countries could have active water markets. And in the Western United States, those water markets don't work very well. And so one of the things that my book, Liquid Asset, talks about is how we could have more effective markets. The second thing, though, is that the private sector can play a really important role in a wide variety of areas. So the private sector can help in creating and stimulating water markets. The private sector is also where we are going to see these new technologies emerge that we need. And there are a number of companies out there who are right now working on exciting new technologies to help us in conserving water, or take that salt water we started out by talking about, desalinating that water. We also, I mentioned earlier, have a shortage of funding. The private sector can actually add additional private financing that can help us meet our financing gap. So there are a variety of ways in which the private sector can play an important role. And that's the whole thesis behind Liquid Asset, is that we need the public sector, but we also need the private sector too. We need all hands on deck.
Buzz, you mentioned that we've got 20th century technology and 19th century law with respect to water. And you're talking about ways to move us into the 21st century. But right now, the things that we often hear about on the news involve water rights that were established at a time when water was relatively plentiful and that are still in effect when the water is scarce. So California, for instance, the state of California claims it has first dibs on the water coming from the Colorado River. Tough luck if Arizona doesn't have any because there's none left. Again, where I grew up in the Central Valley, people would claim that they in fact had the legal right to the groundwater underneath their land, and it didn't matter if they lucked out and had a huge reservoir and other people had nothing. And so the water isn't going to its most productive uses because some people have an abundance and can afford to waste it and other people don't have much. How do we get from here to where we need to go?
Well, the simple answer to that, Rich, of course, is legal reform. The water field, as I say, is really governed by a set of 19th century laws that not only frequently misallocate the water today, because it's based on who got there first, but in addition to that, is not really well suited for markets. We have markets, but the rights themselves, when they were designed and contoured, they weren't designed for markets. And that's one of the reasons why our markets as they exist today aren't particularly effective. And so, one of the questions that I've been wondering is how could we switch from a current system of water rights, which, yeah, you can sell them, but not very well, to a system where you would have rights that would be easily transferable to one person, from one person to another, like real property is. And the problem, of course, is if you just go out there and tell everyone, we're going to have a whole new system of water rights, folks, and we're going to take your current water rights away, um, they're going to sue. And they're going to sue claiming that it's a taking under the Constitution. So I've been working with Paul Milgram, who is an economist at Stanford. He won the Nobel Prize for auction theory. And Paul was really instrumental in the auction that the United States government ran to really convert rights in the electromagnetic spectrum, which were designed for a television and radio era, over into rights that could be used to promote broadband, which is why the telecommunication system works so well today. And I think one of the real keys of what Paul designed was that it's a system where you basically sold in your rights, and then those rights were converted to rights which were better suited for today. And what we're thinking about is a system where if I have a right, I don't want to sell the right. I just want this old fashioned right, which isn't very marketable. Well, okay, you can keep your old right. But if you want a right that you might be able to market down the road, then you have to sell into this new system where you get the new form of right. And I think it's a really exciting opportunity. And Paul right now is actually working on a paper with one of his graduate students to think through the economics of this.
So the idea would be that people would sell their old style right, get a new style right, kind of like when people traded in their lira or their francs for euros.
Yeah, that's exactly the way to think about it. And you can stick with your old right, but recognize that if you ever want to sell your old right, it's going to be very, very difficult to do that in the future. So this is your opportunity to get a form of right, as you point out, sort of like the euro, that is going to be much more valuable in the world in which we live today.
But you're not actually selling the right at the time. You're selling the right to sell the right later. It sounds like a little bit. That is,
So
if you want to keep using the water you now have for whatever purpose you were using it, you can keep doing that. It's just going to be easier for you to sell that water later on. Is that kind of?
that's absolutely right. So you would still have the right to the same amount of water, but some of the contours of that particular right could change. So, right now, if you look at prior appropriative rights, what you get is a right to divert a certain amount of water. A farmer diverts X amount of water. He isn't going to use all that water, and some of it is going to run downstream and be used by somebody else. One of the reasons why water rights are so challenging right now to transfer is if you want to sell that right to divert X amount of water to somebody else, you're not permitted to injure the person downstream who's relying upon that return flow. And yet, frequently, we have no idea how much that return flow is. So if you want to sell your right, it gets into a large administrative hearing and, well, can you really sell that right? And how much can you sell? In California, also, a lot of our water rights actually aren't recorded on paper anywhere, so people aren't even sure whether they have that particular right. So the idea here would be, like in a state like California, you could trade your existing right for effectively the same amount of water. But this time, maybe what your right is a consumptive right. It's not a right to divert a certain amount of water, it's the right to consume a certain amount of water. That solves your return flow issue because now you're only talking about the amount of water you're actually consuming. So you aren't going to injure anyone downstream by transferring that. And you would get a clear right that says this is exactly what your right is. That's an example of how you would move from a system of rights which aren't very transferable because they're uncertain and they depend upon whether you're injuring other people in the system, to a set of rights where injury is far less likely and where everyone's rights are clear.
So, Buzz, are there any examples of places where a system of water rights like this are in place, countries that are doing it right, that we could use as a model?
So the best model for changing a system of water rights to make markets work better is Australia, and in particular the Murray-Darling Basin, which is the largest water basin in Australia. Australia actually did reform all of their water rights in the Murray-Darling basins so that they could be more readily traded. And Australia also did something else which is really interesting. Remember, I told you earlier that water markets only work if you're also protecting the environment and the human right to water. Well, Australia actually spent a lot of money buying water rights for the environment. So now they have this really great water market, but they already have all of this water which is dedicated to the Murray-Darling streams so that the environment is protected. And I think actually Australia did one other thing which is interesting, which is that they created what they call water holders. And those water holders actually have the water right to the environment. And they can buy and sell water in the market. So if they need more water for the environment at some point, they can buy more water. If they don't need everything they have, they can sell some water and then hold on to that money so that they have the ability to buy more water later when they might need it. So I think Australia is the best example there.
Well, that gives us a great deal of hope. It's a fascinating set of issues of how we move from 18th century law and 20th century technology into the 21st century. Thank you so much, Buzz, for talking to us here on Stanford Legal. If you're enjoying the show, tell a friend and please leave us a rating or review on your favorite podcast app. It'll help us improve the show and get the word out that we're back. I'm Rich Ford for Pam Karlan. We'll see you next time.